Good morning, all. My name is Satya Dharmayani. Today, I will present our research entitled The Effect of Chromium 6 Metal on Aerobic Stability of Wastewater Treatment Plant Process, Chemical Engineering Department, University Gadjah Mada Laboratories. Introduction. Laboratory is an important part of a university, especially engineering faculty, in more specifically in chemical engineering. In this laboratory, activities produce waste which can lead to environmental pollution if not managed properly. In the laboratory, Waste Treatment Effort Chemical Engineering Department sorted CED, University of Gadjah Mada sorted UGM, has a wastewater treatment system to treat waste from all laboratories at CED UGM. However, the wastewater treatment plant is not able to process waste containing various types of chemical compounds, so it is no longer in operation. It is necessary for the revitalization of the wastewater treatment plant in order to make operate optimally again. Based on the survey data, there are known that the most common pollutants found in wastewater laboratory is chromium. Therefore, the presence of chromium becomes a major concern in the wastewater treatment process. Some research showed that chromium 6 in low concentration can be reduced in activated sludge. Activated sludge is a biological treatment process that has been applied widely for treating wastewater. The process becomes an option because it has the effectiveness and efficiency of the process as well as has low operating costs. The research premeditated the core of chromium 6 on the aerobic bacteria stableness in the wastewater treatment process using activated sludge at laboratory scale wastewater treatment plant. Experimental method. Equipment used are rectangular plastic tube which has 10-liter capacity, pump 222 to 214 volt. The apparatus set is shown in figure 1. Description for figure 1 is first aeration tank, second is aerator pipe, and the third is aerator. Analytical equipment, UV spectrophotometer, neutron pH meter, neutron DO meter, oven, and analytical scale. Material procedure. The material used are waste milk from the wastewater treatment plant PT Sarihusada, Yogyakarta, aerobic bacterial culture in columns of wastewater treatment plant PT Sarihusada, Yogyakarta. Urea as a source of natural phosphorus and nitrogen source kalium dichromate as chromium 6 source. Research procedure. A. Aerobic bacterial culture. B. Dairy wastewater as substrate include in the aeration basin as much as 3 liters per day. C. In the process of aeration, wastewater is put in aeration pond. D. The volume of the wastewater is kept constant. E. The addition of kalium dichromate as an inhibition as 0.05 gram waste added. Sample analysis. Determination of chromium 6 concentration using UV spectrophotometer with diphenyl carbazide method. BOD analysis used BOD5 method. COD analysis used open reflux method. Mixed liquid suspended solid. ML is done by evaporation and drying of biomass at temperature of 1030 to 105 degrees Celsius. Mixed liquor volatile suspended solid or MLVSS performed by heating biomass at temperature of 600 degrees Celsius. Product analysis. Sampling of wastewater in the reactor was conducted to determine the concentration of COD and BOD in wastewater. The data are used to determine the effect of chromium-6 addition on aerobic bacteria stability in degrading organic substance. Analysis of MLSS and MLVSS also conducted to determine the decreasing of aerobic bacteria after addition of chromium-6. Result and discussion. The effect of chromium-6 adding toward activated sludge. This research was defined into two steps. Those are aerobic bacteria acclimatization and kalium dichromate adding. Total suspended solid concentration which contained in the waste is measured from MLSS level. The analysis result of the solid during the waste treatment is shown on Figure 2. Figure 2 showed the effect of kalium dichromate addition as the function of time to MLSS level. Figure 3 showed the effect of kalium dichromate addition as the function of time to MLVSS level. MLVSS measurement by a further heating for the filtered solid MLSS. With high heat, the component of microorganism will break down and evaporate. The difference in weight before and after a heated indicate the number of microorganisms. The effect of kalium dichromate adding toward chromium-6 concentration. This is due to high level of chromium-6, where feed as influent to be treated by aerobic bacteria are not comparable with the level of aerobic bacteria that will process the metal. The measured data obtained for the addition of chromium-6, 0.025 grams with the lowest measurement data, which is equal to 4.614 milligram per liter, and a decrease in the highest concentration of 2.064 milligram per liter. Figure 4 calculate chromium-6 descents abating and data of chromium-6 descents as office of age. Show that the calculated initial concentration of chromium-6 in liquid was greater than the concentration of chromium-6 final measurement result. It is because in the bacterial cell, the chromium has been reduced into chromium-3 triosulfate stream. The effect of chromium-6 toward the ability of aerobic bacteria to reduce COD of wastewater. COD is an analysis to measure the oxygen demand of the organic substances which are difficult to be destroyed by oxidation, so that it needs support from a strong oxidizing agent in acid. In this research, the treatment for wastewater by using aerobic bacteria showed the COD concentration decreasing with the initial concentration as 56.23 milligram per liter become 26.16 milligram per liter. Figure 5 shows the comparison of COD concentration before and after kalium dichromate adding as 0.05 gram and 0.025 gram. The effect of chromium-6 toward the ability of aerobic bacteria to reduce BOD of wastewater. The ability of aerobic bacteria in wastewater treatment was considered good because it fulfilled the requirement of wastewater as Environmental Ministry number 3 year 2010. The maximum BOD of wastewater as 15 milligram per liter. This is provided by the value of BOD has been reduced from 84 milligram per liter into 4.5 milligram per liter. The BOD decreasing due to the oxygen used by bacteria to degrade organic compound as its nutrients. The aerobic bacteria can be reduced wastewater BOD, which contain up to 94%. Figure 6 show a comparison of wastewater BOD level before and after the addition of calcium dichromate. Acidity or pH. From the pH analysis in sludge in the reactor with the various resident times was shown in figure 7. Figure 7 shows the effect of calcium dichromate as function of time toward the pH of solution before and after calcium dichromate adding. There was an increased pH in the aeration to 55, 56, and 78, and decrease in pH on day 43. A decrease and an increase in the pH value is not significant, which still remains in the range of pH for aerobic bacteria in activated sludge system, which are in the range of 6.5 to 8.5. Conclusion and suggestion. First, conclusion. On the addition of calcium dichromate 0.05 gram, it showed that it inhibits in the growth of microorganisms indicated from MLSS and MLVSS analysis results, which showed the microorganism was reduced for about 35%. The time required to obtain a new stable state with the addition of calcium dichromate 0.05 gram of calcium dichromate and 0.025 gram were for 14 days and 12 days to reach a constant point. Suggestion. There is no information on the repeat use of a maximum of sludge that requires further research on the characteristic on the sludge on a few times it is used. Second, further optimization of the operating unit can be done. For example, by using a variation of the concentration of other metals. The concentration time optimization for the wastewater produced continuously in large quantities and need to be processed continuously. The continuous assessment needs to be done for the optimization process. 3. After passing aeration process, sludge can be used as fertilizer or can be released into the environment. However, requires further research utilization. Thank you.